Good morning.
Morning, sir.
We are here to listen and learn about XEV challenges and designing opportunities of electrical vehicle. It is a great pleasure for introduce our chief guest, Mr. AC Hasifa. So he is in last 18 years in the automobile validation professional who has specialized in electric and hybrid vehicle technology. He has graduated in engineering department and further post-graduated in Master of Business Administration. He has started his career as a graduate trainee in Ashok Leyland. Afterwards, he was working in the various departments like component testing laboratory, the various positions of development engineer, manager, senior manager, in the various durability and innovation and testing of a electrical vehicle. Afterwards, he has posted in the many places and now he is a deputy general manager in the field of electric and hybrid technology. So he has worked in that various electric and hybrid technology, and he has designed a hybrid buses with that collaboration with that Ashok Leyland. He has designed 9 meter to 12-meter length of hybrid buses, and he was working with that valve analysis and valve engineering in the field of automobile engineering. And now I'm going to hand over the session to Mr. Hasifa AZ. So take over the session, sir.
Thank you so much. First of all, thanks for a wonderful introduction. I myself forgot what and all I did in so many years. So thanks for reminding me. That's first. But before we start a session, I think I just pray that all of us are safe during this pandemic, right? We are all offline working with various different modes of working. So I'm just praying and hopeful that all of us, your families and everyone are also doing safe during this pandemic. Today's session, what I'm going to talk is about hybrids, and I heard what Mr. Velmurugan has explained. I was fortunate to be at least at the last part of those session. I joined it. So wonderful presentation. I think it also sets a context of what are the various other challenges that we had. So he went into basics of automotive engineering and electrical engineering. I would take it a step forward and explain or maybe brainstorm along with you. I would not say I'm a tutor here. It's more of a learning curve for all of us. What I intend to show is what is the next steps we have as a challenge in our organization. And also would like participants to be more forthcoming with questions, right? I would like to spend more time asking and answering questions rather than monotonous presentation. So presentation would just be a context to set to ask questions around that. Yeah. And I had especially asked Dr. Karthikeyan to have both mechanical and electrical students for one big reason that the world outside is not one department, right? We have a lot of multidisciplinary, I would say, requirements in the organization. So today, me being a mechanical engineer, I'm leading an electrical domain, right? So that's how it is going to be. So I want both engineering stream students to appreciate what are the differences and where are the areas that they have to work together to ensure that we get answers for the solutions or problems that we have in the field. So you will not get for the engineers, this is for the engineers. If you go to an organization, you will not say that this is a mechanical problem or electrical design. It's an engineering problem. So you have to use your engineering brain rather than use mechanical formulas or electrical design principles. So with living with that, I'm going to shut down my video now just to ensure we have proper bandwidth. I'm going to share my presentation. I'll switch on my video once again after my presentation is over. Okay, so good morning, everyone, again. So let me start quickly. So today's agenda of my presentation is more on talking about introduction, where we're seeing some what are the new buzzwords that we have in EVs, and what are the different perspectives that we could see, and also I'll touch upon something what's happening on the Indian scenario. Next, we'll discuss on the hybrids. I see that this is my personal view. I see that there is a lot of opportunity for hybrid electric vehicles as well. And what my previous presenter, Mr. Velmurugan, also explained about hybrids, and someone had asked this question. So maybe this could be a primer for them as well. And how Indian type applications across other continents could also look at hybrids. The next topic would be on design trends and opportunities, and that's the main part of my presentation today, where we will talk about various advancements in mechanical, packaging, electrical, electronics, software engineering, various other things that you would see we could discuss on the vehicle trends. And last, I would like to conclude today's session with a sneak peek, if you will, in the future innovation and focus areas in mobility, not just talking about trucks, buses, or cars and bikes, but overall mobility, how we are moving. And we'll see some of the areas that are coming up in other parts of the world. And also would like to touch upon something about post-pandemic scenarios, how the transportation and mobility scenario is changing after this pandemic that has touched. Yeah, and with the last part of the session, which would be a Q&A session, looking forward for that much more than this. Okay, with buzzwords, like I mentioned, what are the buzzwords? If you talk about electric, the first thing that everyone talks about is the batteries. So batteries are important centerpiece of this equation. For more important reason, they are heavy and they are very expensive. So for both of these reasons, the batteries have garnered a lot of attention this time. And maybe I don't want to go details, but there are different types of chemistry. We talk about lithium ion, but in lithium ion there is LFP, NMC, LTO, NCA. There are various chemistries that go with lithium ion, and each one has a pros and cons, right? Then comes the power electronics. When you look at powering the motor or the higher voltage electronics, you need power electronics to switch from DC to AC or from AC to DC as required on the vehicle side. Then comes how do you charge? So if you look at charging space, there are a lot of discussions happening even in India about what should be the Indian standard so that everyone in the country would have a charging standard, and you connect to it and your vehicles get charged. So whether it's a CCS2 protocol or it's a GBT protocol or CHAdeMO, or those are various type of charging protocols. So that is one of the buzzwords. The next one is the traction systems or the hybrids, where it's the main item which actually makes the vehicle propel, right? So those are areas of development, whether they are PMSM motors, they are BLDC motors for a smaller wattage power vehicles, or it could be even an induction motors for mid-range applications. Next comes telematics. Why telematics? Right now, if you compare an IC engine to an electric vehicle, you find all of the systems that you talked about here are electrically connected, and therefore there is a lot of opportunity for us to harness this data and look at making some AI or advanced analytics that you could do on the vehicle using telematics data. The other is thermal management. This is not so well spoken of in the industry, but is an actual very important thing. I will like the mechanical teams would appreciate how you do an engine combustion analysis. The same way, the electrical engineers now will have to look at how to manage thermal, because this is nothing but a small board which has heat emitted from MOSFETs or IGBTs that you might have over here. And how do you dissipate this heat so that they work at their appropriate temperature? So now you look at this in my first slide, I'm talking about how multidisciplinary approach plays a role in the industry. Next comes the BMS. This is a loosely talked work. BMS for me is not just the circuit boards to manage, but it also talks about the various sensors that go onto the vehicle. It could be temperature sensors, the voltage sensors, the current sensors. Any of those would be part of the BMS architecture. So you have sensors, you have control boards, and then you also have something called the driver boards to ensure that you are able to have some communication with the vehicle controller to say, am I running the battery safe or not? Now comes when you build an electric vehicle, you also need to test those vehicles. It could be some of the tests that we have on an ICE vehicle, it continues to be applicable even for an electric vehicle. But apart from that, there are various other tests that you would actually do it only for electric domain. That could be either insulation, isolation testing, it could be the motor power testing, the range of the vehicle because of a limited battery capacity. So various EMI, EMC, very important from an electric vehicle development. So all of those are areas that you would see in an EV domain coming up. Important, grid balancing. Someone asked this question about the charging at home in the last session. I agree to the point that India in some states are having surplus energy, and some other states don't have energy even for the basic house, right? Even in Tamil Nadu, we have seen sometimes outages for 1 hour in a day during peak summers. This year, hopefully we're not seeing any outages. But one is availability of power. The other important thing in India is the quality of power. It's not just related to availability, but how good your power is, the power factor, so that all this power electrons that I spoke about, they are very, very susceptible to quality of power that goes inside. They are all three-phase AC, but if the leakage voltage or power factors are bad, you might end up not charging it, or you might end up by failing the system much earlier in the process. So that grid balancing is one important thing. Last but not least, like I mentioned in the start of my slide, we talked about battery. This is also a solution of battery because you can't afford to put large battery packs on the vehicle. There are various solutions that have come up in the recent times for allowing batteries to be swapped. So this is one of the battery that you could remove it and put it in your vehicle, two-wheeler, and take it off for running for the next ride. This is one. Second thing is you are getting batteries for leasing. You don't have to buy the battery. You can lease it for 1 year, 2 years based on your capacity, on your utilization, and you pay per use. So there's other various options that you're getting for battery solutions. So if you look at hybrid vehicle designs, I'm not going to talk because this was well spoken in the last presentation. These are the various resistive forces that the vehicle sees. Now, if you're an electrical or a mechanical engineer, the forces that are acting, the rolling, aerodynamic grade, accelerations, they don't change, whether it's the wheels are powered using a diesel engine or a petrol engine or an electric motor. This is the bottom phenomenon that the motor or an IC engine has to meet. So this is very, very important. And this was spoken about in the last session. I'm not going to spend time. I've actually hidden some slides out of this because I saw that the presenter had already presented this. So this all these forces are non-negotiable because without this, you can't make the vehicle propel on the road. So this is the important piece. Now, what is the difference between IC, EV, and hybrid? So look at an IC engine. If you look at an IC engine, this is a textbook definition where you have a fuel, it goes to the engine, and from the engine, the mechanical power goes to transmission, and you see the arrows, they go propel it into the wheels. Now, what happens within battery electric? So instead you of a fuel, you have a battery, right? And the battery gets to motor, and the motor powers the transmission, and it propels into wheel. You have a double-sided arrow. What it means is when you want to brake or regen, either using coasting or braking, you actually may convert a mechanical power through through a generator mode of the motor to get into electric power to store batteries. So this is the other extreme of battery electric. What is the hybrid? Hybrid is a kind of a solution that you can get the best of both worlds, right? You have some efficiency benefits of this, and you're having some other benefits out of this way on efficiency terms. So we're trying to club both of them and get into a hybrid vehicle. So there could be two ways. One is a series hybrid, wherein the fuel engine charges the battery, and from that it goes to transmission. That's series, and this is parallel, where you have battery going into the transmission and the fuel also going into transmission, whereas regen only happens on this. And therefore you get the benefits of regen into this, and you have idling or cruising speeds you could have at an efficiency using fuel. So there is a series or a parallel hybrid which you get. So this is only to ensure we get the best of both worlds on a same vehicle. But there are challenges on cost, economic of operation and things like that, but this is just an engineering concept. Now, someone asked about different degree of hybridization. This is a good slide that I thought will help everyone understand what are the difference between the different hybridization. So on this, on your left side, you see the conventional vehicle, which is a pure diesel engine or a petrol engine, and on this side is a pure electric vehicle. So you see the amount of combustion engine or IC engine starts reducing, and electrification starts increasing on it. So what is a micro hybrid? Hybrid is nothing but engine stop start. So if you look at during your operation, you just have to stop when it's idling. It's called a micro hybrid. What are examples? Mahindra, Scorpio, or Bolero, I think they have already. And if you look at two-wheelers, so some of you would have driven a Hero Splendor iSmart. That's a bike which has this engine stop during long stops at signals. And if you look at international brands, you might have something like BMW or Volkswagen Passat. They are examples of micro hybrid. What is mild hybrid? It has the engine stop functionality, but it also has some amount of regenerative braking. Now, what do you mean by regenerative braking? You're allowing some of the braking to be recuperated into a battery. You can save some energy. So that's called mild hybrid. They are normally, I'm not saying always, they're normally 48-volt systems. They are either belt-driven BSG, belt starter generator. Those are all types of regenerative braking. And if you look at examples, Hyundai i20 had one, Honda Accord and Civic had, and Toyota Crown has one. And in Mahindra, I think Mojo was actually showcased a couple of years back in Auto Expo. It's still in the works. Then comes medium hybrid. You have engine stop. You also have regenerative braking, but at the same time, your motor is also able to assist to drive. For example, you want to start and stop using diesel engine, but you want to cruise using motor assist. So that means you need a small power motor just to ensure that your constant speed requirements operations could be used using motor. Very few examples of medium, but Toyota Prius and Benz has some more models on those. And comes the strong hybrid. Strong hybrid is nothing but engine stop, regenerative braking, motor assist, plus a pure EV drive. That means the traction system is not able to just assist, but able to drive from stop. That means the power of the motor is equal to the power required to propel the vehicle. So that's an example of strong hybrid is Ioniq from Hyundai is a car which is a strong hybrid. And we had Ashok Leyland had one electric hybrid bus called HiBus. You can do on a Google search. That was a strong hybrid made out of ultra capacitors and an IC engine, diesel engine. And a plug-in hybrid is the same variant of a strong hybrid, but instead of charging the batteries using an internal engine, you charge the batteries using a plug-in. So that's how the plug-in hybrid gets its name. So you will have a charging socket outside. So these are various examples, and maybe this would help understand one slide of what are the different ways to ensure that you are having different degrees of hybridization. Let's get into electric design trends and opportunities. So I will start with first thing is what are the various areas or domains that you would have when you're looking at EV integration. So first is the centerpiece is the vehicle and traction system. So whatever be your mode of powering the wheels, we need to ensure that the wheels keep rotating. And more often for a commercial vehicle like a manufacturer like us, the customer gets money payback only if the wheels keep rotating, right? If the vehicle is dead for some maintenance or breakdown, that means my customer is not earning money. So we need to ensure that the wheels keep rotating. So that's the most important thing from an EV integration. And next comes the energy storage system. Now, unlike diesel or petrol engine vehicles where you can refill your fuel tank and start your journey again in a few minutes, we need to have a conscious decision of how much is the energy storage system sizing and for what kind of applications. Ashok Leyland, for example, has various different energy storage capacities based on the requirement of the application. Thermal management, why? Because the traction system needs to be cooled. Even our IC engines, whether it's a petrol or a diesel engine, also needs a radiator to cool. This traction systems also need. But only thing is that it does not have so much of heat to be rejected. A diesel engine or an IC engine would run at around 33 to 35% efficiency, whereas traction motors would run around 85 to 90% efficiency. So the amount of heat rejection from a thermal motor, from thermal for a motor will be less than an IC engine, but still it needs to be cooled. And you see that there are various different, some like energy storage could be using air conditioned cooling or water conditioned cooling, which I'll touch upon, or it could be just fan, and sometimes you will talk about heating also during cold conditions requirements. The next is the charging system. More importantly, what is the charger that's available commonly? I need to ensure that my vehicle gets charged in any common depot for charging. There's no issues of different protocols, right? So things like that. And most important, safety. Safety is most important on an electric vehicle. We are looking at very, very high voltage, up to 650 volts systems on a vehicle. We're talking about high amperage, up to 400 amperage of current that's flowing on the systems. So a lot of HV, high voltage management on cables and power electronics is required. So these are the major domains of an EV integration. Now let's get into product innovation. So what are the areas that you could look at for? So I have clubbed into 5 major bins. So first is modularity. Modularity in chassis. Why? Because you cannot develop a different chassis or body in white systems for different EV classes. So if you have modular systems, then you are able to share development. You can have one power crane that you can fit in various systems. You can have scale, economics of scale. You can create high product variety. You can go shorter time to market. You can reconfigure your supply chain because now you're having lesser number of parts to procure. And you also, when you look at service support, your aftermarket support, you will be able to get better benefits. in terms of same parts reused in various different classes. If you look at power electronics, one important thing is scalability. If I want to have a power electronic for 1 kilowatt, and if I need the same thing for a 10 kilowatt, right, I should be able to scale it up with the same boundary conditions, so that my development cycles, my testing times, my verification, validation, all of them gets better off by doing scalable projects in power electronics. Also, we are moving towards higher switching frequencies. If you have heard in this thing that we used to use IGBTs, now we are using MOSFETs. Now we are getting into next phase of using gallium nitride MOSFETs. So there are new class of things, still at a lower kilowatt, lower power, but I'm sure that technology is going to go fast to improve the higher switching frequencies. Why? Because if you have higher switching frequencies, you will have lesser losses. And that's the next topic of power losses. And when you have less power losses, you have less thermal losses. And when you have both of these less losses, you can reduce the packaging size. So all of these benefits you get by having an approach to modularity in power electronics. The next is electrical and electronics architecture. We need to look at multi-domain integration, right? It could be a low voltage electronics to a high voltage power electronics integration, talking about mechanical systems like motor, electromechanical systems like motor, to an axle or wheels. So a lot of integration challenges you will have. Now it also goes to the next logical discussion about reliability. All those power electronics that you see today are mostly stationary applications, right? Whether it's we have even a 1 megawatt of system power electronic modules and generator sets and all that, but they're all stationary applications. Now when it comes to automotive, when a lot of issues comes because of vibration, dust, ingress protection of rain, water logging, so reliability has to improve on such. And not to mention about software modularity, where you could look at quickly changing requirements. If you heard about Tesla does a lot of upgrades over the air. Why? Because the software is modular and you're able to quickly update on the same hardware boards by upgrading the softwares. And last but not least in the EE architecture is the communication protocols. I have a slide later which I talk about various protocols, which is mind-boggling on a small 4.5 meter car, if you will, how much protocols are actually implemented inside a small car. We'll talk about that in the later slides that I have. Functional safety, basically it comes from ASIL rating. It's called Automotive Safety Integral Level rating, which is also called as ISO 26262 requirements of how do you ensure that all the requirements, functional requirements of the product, whether it's braking, acceleration, steering, all of those functionalities, how do they meet from functional safety perspective? They are having redundancies in software, redundancies in hardware, so that even if there's a failure, your systems will trigger relevant reactive plans much ahead before the event occurs. So that's something called functional safety. And from a mechanical perspective, lightweighting is imperative, because if you have a lower weight of the vehicle, you will have lesser energy to consume to propel, and therefore you will get more kilometers per same capacity of battery. So lightweighting is becoming a design imperative for most of them, and also from cost management and material availability integration challenges. So various other areas of challenges you will have during lightweighting. Now I'll just have some pictures for what I spoke in the last one slide. Looking at model and design, look at this. This is a base platform, right? So you have validated this design, and look how many more variants you could create. A hatchback, a convertible, a mini van bus, or a truck car, or a camper car. So with the same structure, if you had modular in design, various aggregates can be made. Now look at the possibility, like I mentioned, serviceability. If one part fails, they are all reused in the same kind of a vehicle. So now I have a lot of advantage in my sourcing and development activities. There are other also concepts like you have different systems. You have an engine bay, a cockpit bay, a rear under module, and a front underbody. So using these modules, you can fit into various different classes, right? And create so many more variants. So this is something what CMF common modular family that Renault Nissan has done for that development. This is just examples how you could look at it. The other is EV skateboard design. You'd heard a lot of information and stories about how a skateboard design is nothing but a modular system. Now, if you had all your motors, your batteries, your power electronics, your safety systems, everything packaged underneath like this in a skateboard design, now you're free to do any mechanical design on top of this. So this gets an advantage that the customer will feel he has got different vehicle, but under the hood, it is the same configuration with same power electronics. The other is REE, is one of the things which is went much further and not even having this. It's a complete flat bed where it's an hub motors connected to the wheels, and then you're having power electronics and the battery, everything connected to this on the chassis. So now it allows you to get the complete space for either a commercial car or a personal car, right? Comes the battery packaging modularity in this. Like you see various options. Now this is half chassis, half underneath body, where you're looking at the batteries here. And if you look at a bus, you have options to place your batteries on the roof, in the underbody, or in the rear side, or on the saloon inside, or in the front where the engine used to be, so that the saloon space, or what we call the passenger space, does not get affected because of an electrification. So we could have a swap battery, a one unit, or a distributed packs in series or parallel, and it can depend on the capacity, how many units do you want for the range requirement and the locations, various locations. Next comes the charging. There are two typical ways of charging on a vehicle. One is the AC charging, the other is the DC charging. We all know that the battery is a DC source. So in any which case that you want to charge, you need to finally convert it into DC. So if you're having an AC charging, that means you're taking power, alternating current from the grid, having an onboard charger to convert AC to DC and gets into the lithium-ion batteries managed by a BMS. If it's an off-board charging or DC charging, the charger, this power electronics is now part outside, and you're giving a DC source, and the DC gets directly get into a BMS. Now, in this case, the BMS talks to the DC charger to tell him how much power is required or how much current and voltage is required to ensure that the lithium-ion batteries are safely getting charged. Now, both has an implication. If it's a personal car, you would like to have an onboard charger because you don't want to install a fast charger. So this might be a good option to have an AC charging for a personal vehicle. But if you look at a commercial bus or a Ola, Uber kind of a commercial car application, they, instead of having the infrastructure on the vehicle, which increases the vehicle cost, you might want to keep one charging outside so that you can service many vehicles using one charger. So that also gives you an overall efficiency economics in the infrastructure development. So that is different types of it. This is from the context of commercial vehicles, but some of them are likely to be also part of a car or a bike thing. One is the overhead charging lines. We have this like a tram, but no rails on the road, but you're having rails on the top to take off it. So there are some applications like that in Sweden and in Scandinavian countries where overhead lines are very popular. The other is pantograph. So you see this is like a panto, which gets connected to the stationary charging board. You take the vehicle there, charge it, and you can move quickly. So you might have a different kind of chemistry to pump in large amount of power in a short duration. The other is plug-in charging, a very typical conductive charging using one gun or two guns to get into your vehicle. So you have a charger off board, you have a charging. This is typical of plug-in charging. The other is induction charging. Teams in IIT Guwahati, even in India, are working on how to make inductive charging. So you have a primary coil on under the ground, and you have a secondary coil under the bus or a vehicle car. You're able to inductively charge your vehicles. Now, many of you would be using phones which are having wireless charging. This is the same principle. And electronic engineers will understand a primary circuit and a secondary circuit to charge power. So same thing at a very, very high capacity power and current rating is being used. The last but not least is a different kind of a charging. I would not say vehicle charging, but battery charging, which is called battery swap. So this is a swapping station where you have batteries over here, which you see small. I think they are batteries, and these are the other batteries that are on the vehicle. So a swap vehicle would come into the garage. The automatic stations would pick up the spent batteries. The finished batteries will be removed from this. It'll go into the charging station and put it on that and take a fully charged battery and put it back into this, and the vehicle runs. Ashok Leyland, if you look at Ashok Leyland, Google it up as Circuit S bus, you will find even the swapping mechanism, how a big battery could be swapped in less than 4 minutes or less than 3.5 minutes to get back. So this is just like fueling your diesel or petrol in 3 minutes and taking the vehicle out. So that's one of the concepts that Ashok Leyland did for swapping. Next comes electrical and electronics architecture. So what you see is today, where we are is somewhere between this integration and centralization, where several ECUs, so for example, there is a brake ECU, there is an ABS, EBS, the engine ECU, if it's a hybrid, it's a BMS, there is a cooling thermal cluster. So there are several ECUs which are getting integrated, and more when you look at electrical. So today what we see is something like a centralized domain control units, where a lot of domains, for example, could be a thermal domain, this could be a traction system, this could be brakes and safety, this would be steering and safety, all of them managing those small ECUs. So this is called centralization. What we are going towards, this is again from a Bosch E architecture, what they predict in the future in next decade or so, where we are moving more about fusion, where several of these ECUs are getting into fusion, and more importantly, getting into cloud. You see this flashing over the air, FOTA, flash over the air. Flashing over the air is becoming a common terminology in this in this domains, and this is something that is available now on this. And going forward, it'll be more of cloud. It's not just flashing over the air, but the management of AI would go on the cloud, so that large amount of computation for that vehicle would be done on the cloud, and specific actions are taking on the vehicle. So this is how this has been envisaged by Bosch, and we are moving, and we see more evidence that we are moving towards this idea of architecture development. So for electronics engineer, or even computer science engineers, this is where the area is of development about safety, protocol safety is how do I communicate. When you look at electrified roadways, I'm not sure if you have heard of electrified roadways, wherein each electric pole has a Wi-Fi station as well. So as you keep moving the vehicle, the way the Wi-Fi system picks up your location of your vehicle, gives to the central server, and then it tells where should I jump, run at X kmph to avoid a signal, or should I take a left turn or right turn to reduce the distance because there is a traffic in the upcoming signal. So things like that would be used using this cloud principles. Let's look at electrical routing. Coming back on the vehicle side, there are going to be a lot of high voltage, low voltage systems on the vehicle. Now, anything that you see orange in color on a vehicle, electric vehicle, please be aware they are all high voltage. This is an industry standard that all high voltage cables, and when I say high voltage, is anything above 60 volts is considered to be high voltage. So all of them would be in a orange color package. So that's one important thing. Also, a lot of infotainment, sensors for autonomous ADAS related things are coming up, right? Rear view, front view. So there's also a lot of electrical harnesses. Now, when you look at challenges, you have high voltage cables, low voltage communication cables, it automatically raises a concern of EMI, EMC. The electrical engineers would appreciate, from mechanical engineers, it's nothing but a noise that gets picked up by low voltage electronics or high voltage electronics, because of its high frequency switching. So if you look at low voltage, you would see because of the oscillators inside the or clock oscillators inside low voltage electronics like ECUs. And in terms of high voltage, they are because of the high switching frequency. We heard about 500 kilohertz, 15 kilohertz to 600 kilohertz of switching frequency to convert AC to DC or DC to AC. So they lead to EMI, EMC. And when they have this noise picked up, you'll file interference, and it might be not a good sign for a low voltage electronics to give commands, because it's getting noise. Therefore, the commands also will be noisy. Obviously, when you talk about high voltage, you need to talk about fuse, contactors, relays, and switches. How do you design that for technical safety of it? And most important is when you have a crash or when you have an accident of an electric vehicle, we need to ensure that all the high voltage systems that we are having are known to the first responders. When you see what are first responders, who are they? They are either the public who are going to come and help to remove the passengers, to extract the passengers, or it could be the fire tender guys. The first responders could be fire tenders who are going to come and help the thing, or it could be even the service personnel to come and allow the systems to work. So when you're welding, cutting, or extraction of people, we need to know where to cut. By mistake, you should not cut a high voltage cable which is already under stress, and you cut it, you might get electrocuted. So to avoid that, a lot of safety that you need to ensure during service and repair. Now, quickly, power electronics, we heard, and you guys would be knowing that we're talking about IGBT modules and MOSFETs. up to 1 kilohertz to about 3-4 kilohertz up to 10 kilohertz. You're looking at MOSFETs, and power you got up to the 5 kilohertz in MOSFETs and up to 10 megawatts in IGBT. So this is mostly used in stationary applications, and this is mostly now being used in our automotive application. But there are several new modules that are coming up, which is called silicon carbide and gallium nitride. So these are new age, which allows us to move both power wise and frequency wise, right? So both of this is helping us to move that in that direction. Just examples of how switching losses, just example of how switching losses could be reduced from a standard silicon to the silicon carbide. Up to 50% losses can be there, and there's a paradigm shift that's happening these days on managing the magnetics, the electrical EMI, EMC, and to reduce the system cost of development. Thermal management, I trying to put it very, very simplistic for so that all of us understand what thermal management means in an electric vehicle. So I put it in X and Y 2x2 matrix. So you have air and liquid on your Y-axis and ambient and condition on your X-axis. Now, what are the options? If you had an air cooling and ambient, it's nothing but fin cooling. So they are nothing but natural convection. You could have, this is a module, an IGBT module, where you're having this small amount of fins, aluminum fins to extract heat from it, whereas the power module connection, electrical connections are here. Or you could have a forced fan to extract heat. So that is nothing but natural convection. So it's air and it connects to the ambient. What is liquid? You have the same IGBT modules. These are all black color IGBT modules, and there's a cooling pad below it. So you are taking to water, which goes to the radiator, and there's a fan which takes heat extracted, and it goes back to the power electronic modules. If there are several water blocks or the power modules, it takes. So that's nothing but liquid and ambient. It's still in ambient because you're extracting the heat from the water to the ambient air using fan. What is air to condition? Is an HVAC unit. So it's nothing but you are able to cool the air, and the cold air goes into a battery. So this is an example of a battery. You see a blower cold water, and the cold air goes into a battery module to cool all the packs. It's like a small air conditioner inside a battery pack to allow the cooling of the packs. And finally, liquid and condition. It's nothing but two circuits. So you have an compressor and a evaporator circuit on the gas side, and you're having a water from the condenser going to the thing. So you have this such kind of thing where the water and the cold air gets exchanged in this heat exchanger, so that you're able to cool the batteries of power electronics. So this is a simplistic of thermal management that we have on a vehicle. So you will appreciate that some of the power electronics could use this, some could use this, some could use this, and so batteries would normally be in this kind of a category, and power electronics could be either this or this. So these are the two things that you could look at for development. Lightweighting has a very big impact. It's a misnomer like light and heavy, but yes, this is a big impact, because if you look at materials, there are various types of materials that we see, starting from high strength steel, aluminum, carbon fiber, magnesium, titanium, fibers, and various types of forms and plastics. So all of this are actually contributing to it. So this is a typical example where you're seeing different colors, and different colors are areas of which each different type. Not all could be steel, all could not be magnesium, because it becomes cost impact, or could be even various joining processes. For example, like mentioned about joining processes, where you need to fasten, rivet, weld, and others. So you can't weld a fiber with an steel, or steel and aluminum. You might need specialized riveting or adhesives. There are good adhesives these days. So for example, you look at this as a carbon fiber which is actually pasted on an aluminum to increase the strength. So there are various joining processes. So based on this, you would have to decide how your vehicle would take care of this. And important is design. Look at this picture that you see. Each one would be a different design requirement. One could be for structural member, one could be for aesthetics, one could be for thermal conductivity, one could be for crash. So all of these different requirements will allow you to talk about what design philosophies to use, and more importantly, to talk about cost, manufacturability, availability of those raw materials. How do you repair? In India, we don't like to replace parts, right? We go to tinkering shop and want to repair it. So if you're having a very exotic carbon fiber or a magnesium thing, you might not be able to repair. That means the replacement cost increases. And most important, which no one talks, is the recycling. As OEMs, we need to be conscious about what materials do we use, so that when you scrap that vehicle, we don't end up in not able to recycle those components. So we try to reduce the number of items like FRPs and all, which are thermostats, and you cannot recycle. So we would like to avoid such kind of a non-recyclable material. So that's important when you look at a design perspective. Last few slides. Am I on time? So on environmental factors for design, you would have understood from this picture. Picture talks a lot of word in India, even in Chennai. I would see more of this, right, than any of this cooling. So we are always hottest. But when you design a vehicle, you need to ensure that this vehicle would also be used in Ladakh, Leh, and it could be also used in Rajasthan, or it could be used in Delhi itself, where in some months of the year will be having hot, and many other months you might have rain or cold. So we need to ensure the environmental condition while you're doing the design work. Uh, uh, Important, India is a mixed and very different in different parts of the country. You would have highways which are absolutely like a 6-way, 8-way lane, perfect road conditions. At the same time, you'll also have conditions where they are potholes, something like this. So this is a normal scenario. You can't avoid this in your design. You need to ensure that your systems are durable for both conditions, whether it's mechanical durability or ingress protection for water inside the power electronics modules. Water locking, this is a site from Mumbai. When there are floods, we have floods covering up to the height of a tire, which is about a meter from the ground. So if you have to package components, high voltage components, we need to ensure they are protected so that the water does not get into the power electronics issues, because you might get short circuited and things like that. So design considerations should be there to either use better ingress protection components or ensure that they are packaged much high so that the water does not touch them very often. Right. The next is the traffic conditions in India. When you look at least for my domain in buses, this vehicles, when you look at saloon AC, air conditioning, or cars when you want to air condition, if you are only planned for duty cycle, the battery capacity only for X kilometers and not for time, your energy is zero for propulsion while standing, but energy for HVAC, the cooling system is always on. Therefore, you need to ensure that your capacity takes care of such traffic conditions as well. Not to mention dust. Some of the in the previous slide I talked about convection, right? The cooling using convection, but the convection becomes a bane rather than boon, because if the dust gets accumulated on those power electronic components, the thermal heat conductivity gets lowered, and therefore you will have problems with those efficiency of those converters. So we need to ensure that when you size or you look for what thermal system that you want to consider, this is also an important factor. Last but not least is the driver behavior. A driver, if he had a good day in the morning, he might drive with very efficient ways of driving. And if he had a bad day morning, he might drive it very coarse. So these systems, just like diesel engine, you get different average efficiencies based on driver. Electric vehicles also are having considerable effect on the driver behavior. So, and while we sell electric vehicles, our electric buses, we also have a driver training program to ensure that the driver understands how to run an electric bus so that we get the best efficiency. If just as a term work, maybe you will lose efficiency up to 20% just because of a driver behavior. A good driver versus a bad driver, you could lose up to 20% efficiency. That means 20% of your range can be lost just because of a driver habits. Yeah, so coming to my last part of the presentation is future forward. What would you see in the upcoming slides, where in the upcoming generation in terms of mobility areas, right? One is multimodal transport. We have seen even in Chennai, people who are based out of Chennai and many other cities in the country, you would have 2-wheelers, 3-wheelers, 4-wheelers. This is a single deck BRTS, it's called bus rapid transport system, which is used in many parts of this country, where you have dedicated lanes for buses, you have double decks, you have overhead metro rails, and you also have suburban rails. So that is going to be multimodal transportation, which is going to be becoming a norm. It is there in many countries. It's just happening in India now. The parking areas, you will see they become as charging areas also. A park come charge is what you will see, not just on the roads, but also in malls. If you visit a mall in future, you might see that there'll be dedicated space where you could say these are 10-20 bays for charging electric vehicles, and you pay per use. So that you'll see parking charging as an areas of innovation. The highway speedways, this is happening in some parts of Chennai also, using flyovers and high speed lanes just to ensure the distance is reduced. It helps at an overall country level to reduce the carbon footprint. Because if you had to stand in the traffic and travel at 1 kilometer, you could spend in 10 minutes to go over a bridge. Then you are saving so much of carbon emissions and fuel. So that also helps to improve highways and speedways. Smart roads, I spoke about this in one of my previous slides, where the poles are actually a source of information to the vehicle, and they're also a source of information to the transport authorities or a road authority, who will tell you about how to manage the traffic signals, how to ensure that there's a information exchange between the vehicles. So smart roads are becoming a small amount of reality in the world. VTOLs is nothing but vertical takeoff and landing. This is, again, like I mentioned, this is not something to a commercial road transportation, but it is more of a mobility, where you will find that VTOLs are now becoming electric. So it could be a two-seater VTOLs to take off from one building to another building. It's a vertical takeoff, so you don't need a driveway to run at speeds. So this is becoming a reality in electric vehicles, and there are several startups in US and in Europe. They are only working on this VTOLs. Traffic density. One advantage of having electric vehicles and a smart road could be that, for example, today we say we should have a distance about 1.5 meters between two vehicles, right, to ensure safety. But in India, we don't even practice this bumper to bumper. But even if it's bumper to bumper, if your vehicle are told that there's going to be traffic, some of these vehicles in the rear could actually take a diversion and go some other route. Since they don't know how long the traffic is, people stand in queue. So there could be a lot of innovation in how traffic density could be managed just because of having a lot of information going to the cloud. Mobility individualization, this is more pertaining to the last couple of years because of COVID. People are moving away from public transportation and trying to see, how do I get a personal e-pods or a cycle or things where they're looking at personal mobility. This is coming back into an option for mobility individualization. It's just like you are having your phone with your wallpaper everyday change. You might want to look at this also as something like that. That's something areas of innovation. Grid balancing, this was started in my slide earlier, and this is important because a lot of innovative thing has to happen of how to manage a grid supply for a city. Like in the previous presentation, it was told that will you have enough power if everyone in the country, in the city, had electric chargings, right? If everyone charges their vehicles in the night, the city will not have so much of power. So you'll have to apply for more transformer space, and then you will have to bring a lot of large cables into the center of the city, which itself there's no space for people. Now you'll have to start putting substations. So that's what the impact will be on innovating some idea, having some innovative ideas to manage the grid during charging. Battery tech and solutions, I mentioned about leasing and various other options for swap for battery tech solutions. And digital tech assessment, assets management is going to be one more where I'm going to go quickly to the next slide, which talks majorly on digital assets. So you're going to have UBIs called automotive usage-based insurance. Now we all pay for bikes and cars an insurance premium based on the book value. But in the future, based on how many accidents, how many speed tolls did you break, how much was your average kilometers per driving pattern, and all of this would be available in the cloud. And you could have an individualization-based insurance. So if you're a good driver and a responsible driver on the road, then you might have to pay a lower insurance premium. So that could be one of the areas. Connected and self-aware driving vehicles, autonomous, various levels, they call ADAS, automated driver assistance systems, where the levels 1 to 5. So based on the conditions, you would go from 1 to 5 ADAS or autonomous vehicles. Vehicle health tracking and monitoring, this is more from OEM's perspective. So before the vehicle starts failing, you could recall that vehicle and say this needs a scheduled maintenance, and therefore you call it, so the downtime for the customer is lowered. Digital buying and sharing, you have Cars24 and many other areas which has already started looking at digital buying and sharing. It starts giving you points that this car is so much pointer, and therefore you can pay so much for it. So this is an example of how digital buying and sharing is happening using of digital assets. Truck platooning, this is another way of autonomous vehicle, but it's not a complete autonomous vehicle. The way this is, you can think of, there are 10 trucks going from point A to point B. Just imagine Hyundai factory has about 200 cars to be transferred from their plant in Sriperumbudur to the port at Chennai. So they're going to be back-to-back so many vehicles now. How do you do truck platooning for that? The first truck which has those vehicles will have a driver who will be seated, and he'll take control of the road. and all the other 9 vehicles behind it could be actually an autonomous following the first vehicle. So the driver is still driving the first vehicle, but behind him, all the other 9 vehicles are following the first driver. So that's called a truck platooning. You can do Google search to see how truck platooning can be achieved. Augmented reality, more importantly from training. Now today what we're doing today is an online webinar, right? Had it been a couple of years back, I would be sitting in your campus, in your auditorium giving this presentation. But today we are doing this. But going beyond that is augmented reality, where you can have some sensors on your body and the systems, and you can actually do a physical training of a service or do the thing using augmented reality principles. V2X and V2G is vehicle to grid, vehicle to vehicle, vehicle to home, home to vehicle. Various options are available right now to charge your batteries from the home center, or you to power your home via your batteries in your vehicle. All of this is happening with this V2X and V2G grid. Blockchain, it is more of a computer world or more of a computer science domain, but it's getting into more of business domain. How you could look having your vehicle in blockchain. There's something called ledgers, right? And all the transactions of the are captured in a ledger. So in this case, on an electric vehicle, all the discussing whether it's a speed limit defaulting, or could be accident, or could be signal jump, all of them would be part of a ledger, and those this ledgers could be used for your UBIs. So that is how the business management occurs in the using digital assets. Last but not least is something called mobility as a service. So you have software as a service, which is very common these days. You don't buy software, Microsoft, even your Word, PowerPoint, you can hire for few small value per year subscription, right? Your Ghana.com or Savan.com gives you all your digital tunes and all of them on. So as a service, you don't need to buy anymore now. So those are all. So in the same way, mobility as a service is coming up, where you don't buy the vehicle, you buy it as a subscription model. So you say, I'm going to pay you X rupees per kilometer, and so many kilometers in a month I'll pay for. So you don't have to pay the upfront cost, because electric vehicles are expensive, but you could buy it as a subscription models, right? So these are all various advantages of when future mobility using as digital assets. Now, what comes to you? What are your areas that you could excel, right? One is in Indian context, Make in India, with a lot of companies who are developing the hardware, whether it's the motors, the controls, the BMS, the battery integration. So these are areas of it. The power electronics, I mentioned, India is a good resource pool for developing power electronics, and this we can only take more strengths out of it to develop something for the automotive industries. Design and simulations, all of many companies in India are doing simulations and design for IC engines. The same teams are now gearing up for doing the simulations and analysis for electric vehicles. It could be either thermal, electrical, mechanical, all of those are part of design and simulations. Interestingly, software engineering, which used to be more towards computers and clouds and things, are now getting more realistic into automotive domains. This is an area where a lot of codes are being written for safety, for interaction between various controls on the vehicle. So this is again a domain which you can look out for in your future. Data security and analytics, again from data that is available on the vehicle. You don't want someone to breach your software when you're running at 70 km/h on a highway and say that break the vehicle, right? If you apply brakes suddenly because of someone playing around with your software, you might get into a severe crash, or someone else from the rear could hit you, because they will be assuming that you're running at 70 km/h and suddenly you applied brakes. So things like that, it's important from data security and analytics of in terms of doing autonomous vehicle driving. And last but not least, a lot of institutes are doing training these days to how to manage an electric vehicles. Just like today, you could go to any mechanic shop on the road and get your diesel or petrol engine vehicle repaired. You can't do that currently with an electric vehicle, because there are a lot of nuances on safety, the controls and things like that. So maybe one other area that was going to be grooming up is areas of training on high voltage safety, how to approach a high voltage issue and how to deal with that. And my last slide, I think I now have 4 more minutes, and I'm going to wrap it up with this last slide, which is mobility trends post for COVID pandemic. Well, first we'll look from a people perspective. So how passengers are looking at mobility requirements post-COVID. So there is a reduced need to access mobility, work from home, learning from home, telemedicine, e-learning. They're all modes of it which has reduced people to move around. And last 1 year, we have seen that the alternate methods of training is possible. Right? Maybe not so much for physical laboratory type of working, but many other ways that could be reduced mobility needs. The other is new focus and expanded definition of safety. When earlier it used to be safety, it used to be safety of the vehicle for crash, or to an extent it will be safety of women passengers on a vehicle, right? It could be for safety for buses in the night travels and things like that. So more than that safety, now the system is moving towards sanitary and hygienic. How whether the systems are, or the buses or the cars are sanitation wise hygiene, are they doing sanitation every trip? So there's a different explanation of safety beyond just the physical safety. Many people have moved from shared mobility or to a personal mobility, like start people were using bikes and cars. And there was a report which showed that there was a steep increase in procurement of bikes in the last 6 months or 8 months post lockdown, last lockdown, because people wanted to go to office and work on bikes because the public transportation was not available, and they continued using that. And incidentally, which has also been seen in a large number, is sale of bicycles have increased for two reasons. One is obviously to have personal mobility, and more importantly is from health consciousness. People are now looking at how do I ensure that I am becoming fit by using day-to-day activities, combining them with my day-to-day activities, and nothing like a bicycle where you could have some physical exercise at the same time reach your destination on your personal mobility solution. Now, coming to the transportation industry in terms of goods and logistics perspective, long haul and last mile movement is getting autonomous and electrified, basically because of e-commerce and online buying. All of us are participative to that, because everything that we go and buy online, that means more of number of vehicles are required to move them, and that's something that we see as a larger trend coming up. Automated delivery via robots and drones, earlier which used to be a fantasy, is now becoming a reality. People send pizzas and things like using robots and drones, just for ensuring social distancing, and also helps in operating economics. Data encryption and security at all levels of value chain. Earlier, we were booking something, we used to go to the kirana shop or go to a mall, buy things and come. So there's not too much of data encryption. But now with the advent of more e-commerce, there are levels of safety that have been enhanced, so that whether it's Flipkarts or Amazons of the world, you have visibility. At the same time, you're able to make transparency of whatever online histories we had. And from a commercial vehicle, from commercial business perspective, it also helps them to be more agile, and the decision making is more data driven, because all the information is now available online. They're able to say which part of the country or which part of the city needs more online booking, and can I build a warehouse there, so that my time to deliver components could be faster. Other idea is coming. I know these are the common things that people ask very often in this area. So can I stock some components, some units beforehand, so that I can deliver to my customers quickly? And that's how Amazon says if you book it in next 2 hours, you can get by the end of the day something delivered. This is nothing but ideas that you've got from the database driven. So it's either ERPs, enterprise resource planning, transportation management systems, or warehouse management systems that helps us to be more agile, and the decision is made on data and not just of some gut feeling or intuitions. So this was my last slide. Hopefully, I'm just on time. It's 12 noon now. I had shown you a cap of what we discussed in our agenda in terms of introduction, hybridization. We spoke about various design trends, and I had ensured that there was some amount of mechanical, electrical, thermal, software, all of those domains, and you would now appreciate that how the new age technology development is not any discipline. It's more of a multidisciplinary approach, and that's how we should start looking at problems. And in the last few slides, we spoke about the future of mobility, and what are the areas of domains that we have, which we see more prominently growing up in the country. And the last slide was about mobility trends in during post-COVID pandemic. So that's it from my side. Question and answer session. I will appreciate if participants can ask me questions directly, or if someone can help me moderate the questions if they are already in the chat box.
Yes, sir.
Good afternoon, sir. I am Tamil Arasi from Marine Engineering Department, sir.
Yes, sir.
Sir, I have one doubt, sir. How can, is it possible to include fuel cells in electric vehicles, sir?
Very much. I think there's a question earlier also. Fuel cells are examples of range extenders, right? What we do is you have instead of a diesel engine, right? What we have, we also have a fuel cell. So now instead of diesel engine powering through a generator to charge the batteries, what we do is we have a fuel cell which gives an extra power to the batteries to charge. So there are two ways. One is called charge sustaining and charge depleting. So if it's charge sustaining, that means it ensures that the battery SOC values are constantly there. It's called charge sustaining. And charge depleting is you allow the batteries to go from one SOC to other SOCs, and when you come to a threshold SOC, you can recharge it using fuel cells. And Ashok Leyland and many other companies are working on fuel cells to ensure we can have large, long range. I mentioned about the capacity, right? If you're having a 500 or 600 kilometers range requirement of a commercial vehicle, you will have to have 3-4 tons of battery. And the 3-4 tons of battery means so much of less payload, right? So it's only detrimental to that. But if you're having an onboard generator like a fuel cell or an hybrid or a small engine, right, to make it only charge sustaining, we can do that. So yeah, fuel cell is an option that you can look for long haul applications.
Okay, sir. Sir, in the designing part, where can I start the design, sir? In which place? That is designing parameters. Which parameters I have to start for designing the electric vehicles?
So most important, I think the presentation that I had earlier, the aerodynamic forces, the drag forces, the first is the physical mechanical parameters. From that, you would science the motor. And from the motor, you will say what will be battery capacity. And battery capacity is on two things. One is the power required to drive the motor. And second thing is how long you want to drive the motor. So that talks about the range. So with this two combination, you can size motor, the power controller, and the battery. And if you want to talk about charging, you will have to say whether you want to have an onboard charger or offboard charger. That will depend on your battery capacity. How much C rating? We call C rating. So what is the C rating that you want to charge the battery? So that will define the charging capacities.
Okay, sir. Thank you. Thank you.
There are some questions in the chat box. The first question is Ashok Leyland or Indian manufacturer is having long-term plan to manufacture electric-driven vehicle only?
No one would say yes to it. Honestly speaking, no country in the world, even the most advanced countries like Scandinavian countries or Norway, Sweden, they are supposed to be the front running in electrification. They haven't converted to 100% electrification. I'll tell you the reason why. Because there are options where you would not be economical from business wise to give pure electric. Just like I mentioned about long haul, if you want to go from here to Bombay or from Bombay to Delhi, right? So these locations, you will need about 1,200 kilometers range. But a battery does not make any sense. So no company would have pure electric in a long term. There will be some percentage which will be diesel or petrol, and it will continue to happen.
Thank you, sir. The next question: how can we improve the regenerative brake system in EV?
So regenerative braking is, you should consider two reasons of why regeneration happens, right? Whenever you accelerate and you brake, you regen. Now, if you don't have acceleration and if you have a smooth driving cycles, you will not have so much of regen. So how do you maximize is more important from the drive cycle rather than the design side. You would maximize from design, but what you actually get is based on the traffic condition. If your traffic condition allows you to for a smooth long distance drive, you can cruise at X speed, then you will not see regen. So it is a difficult answer of how to increase, but yes, you can increase. The other way that you could do is something called coasting. What do you mean by coasting is you don't have your act pedal and brake pedal. You don't have your foot on both of them. You've taken the foot from both of them. The vehicle is cruising, right? So automatically because of friction, it will come down. So while it's coming down of its own friction, you can start recuperating energy. So that's called coasting regen. So brake and coasting are two ways to improve regeneration efficiencies.
The next one is you spoke about the AC charge at home and DC charging sessions. It's possible to get supercharge in AC chargers.
No, it depends on what is your battery capacity. Supercharge is a misnomer. It depends on the power. It's a relative, right? When you say supercharge, are you talking about 500 kilowatts? Yeah, or are you talking about 10 kilowatt? So that's a misnomer. But yes, you can't do a charge. I would say you can't power your charge power beyond a point, because your normal home charging allows you only up to 15 amps, right? So 15 into 415 volts is about 22 kilowatt. That's the maximum you can charge through your outlet on your home line. If you had an industrial power, then that's a different thing.
Next question. What are your thoughts on new Mercedes EQS?
Sorry, what is that?
Mercedes EQS.
I'm not sure. I've not seen too much of it. Maybe
Okay.
the participant can ask the question, what is the expectation? I will answer.
Your thoughts about Mercedes EQS? I think it's a new variant of the EV.
Maybe I'm not sure. Not heard. Sorry.
Okay. Okay, sir. Sir, can you give practical training for faculty in your company? Is there any possibility?
There is no faculty training, but this kind of the same engagement that we have with in the industry and institutions are basically to impart knowledge where we have. But if you want to get training, there are some institutes like TUV, right? TUV trainings. They give you training on high voltage trainings on those systems, and they're having some 1, 2, 3 levels. One is people who are working on mechanical but on an electric vehicle. People who are working on electrical but not on high voltage, and level 3 is you're working on an electric and going to work on high voltage. There are 3 levels of training that you give, and that's a certified course. So maybe I would urge the faculty to go through the training so that it helps them to understand and help them when they're training the other student members.
Participants, if you have any doubt, you can unmute yourself and ask.
Yeah. So can I ask about
Yes.
I have seen many articles and videos where we see Germany and other countries focusing too much on renewable energy. So what I found in one video was what he said was due to renewables, due to only the active power which is being present, and there is no inertia in the systems. There are a lot of other systems, ancillary services which we have to provide. So in the long run, we see that the electricity cost, per unit, what we pay is increasing. So can we see the same? Am I thinking correctly? Is it going to be the same in India? Because India wants to do 200 gigawatts in renewable itself. So when this large amount of renewable energy comes into the grid, so maybe the cost of electricity per unit also may increase.
Yeah, so I'll tell you the difference. So we, unfortunately, we are close to the equator line, right? We are seeing so much of more sun in our country when we compare with Germany and other Scandinavian countries. So for them to get renewable energy from solar is going to be expensive than us, because the amount of energy, what we call irradiance.
Irradiation,
right?
Yes.
Yeah, so the irradiance value for India is much higher than any other country, at least from. Maybe not, I'm not comparing Africa, but yes, at least for Indian in an Asian context, we are much higher. So what we have, this 200 gigawatt of solar energy is only going to make us cheaper in terms of getting the energy. But what is going to be expensive is how do you transport it? Because this solar energy cannot be stored. If you want to store this energy, you'll have to either put it on a grid and give it to a consumer and shut down your thermal power plants. Otherwise, you might have to have batteries to store this energy. You understand? So
Yes.
storing this is going to be expensive rather than generating it. So if you are able to generate at point of use, so if it's called point of service, POS values, if you are able to generate it at the location where you want it, it's going to be much cheaper, right? And when in the country, when the bidding happens for solar energy, people sell it much cheaper than what you pay. We pay about 6.5 rupees per unit, right? you will be able to get solar at around 3.5 4 rupees also.
Thank you, sir. Thank you.
The next question is, at what extent the electric vehicle will be efficient in hill stations, particularly uphill travel?
Uh, they will not be efficient. Just like in petrol or diesel vehicles, you will have a decreased efficiency, right? When you're taking a diesel vehicle or a petrol car, if you go up the hill, you will find lesser mileage at a kilometer, KMPL you'll get. The same thing is with electric motors, no change, because the ground rules of mechanics of propulsion does not change. But what happens with this is that when you're coming downhill, the region also helps you to recharge the batteries. So if you're having like going on a hill and flat road, going on a hill, downhill, uphill, you would get a better efficiency because you are able to regen something where you were not able to regen with a diesel. Apart from that, more importantly would be the hill hold requirements and the traction motor sizing to go up the hill. That will be important to consider values designed in the vehicle itself.
Sir, this is Jagdishwari, sir, from Chupri department. So in case of SRM motor for electric vehicles, what is the latest controller, sir, especially for the SRM motor?
I think SRM motors, synchronous reluctance motors, there are no specific controllers, but what I know is people like Infineon, there's another company called Semicron, and there's one more company called ST Microelectronics. They have developed some modules which you can use it, but more importantly, they are being used. They take the blocks of it and they develop the controllers from it. So you will not get an SRM motor controller out of the box. There are building blocks that are available, and SRM is more of control logics and firing rather than more of development. It's more of, I would say, it's development rather than the hardware itself. Hardware is available with many Semicrons and Infineons kind of it.
So one more question from the student side. In order to get a job in electric vehicle domain, what are all the things that the students have to learn or how to prepare?
Like I mentioned in my slide, one of the slides are different domains. So if you are interested in one of the domains, you can pick up those areas of expertise and look for it. Power electronics, thermal systems, simulation analysis, software engineering, data analytics, big data analysis. All of those are various areas which are important to automotive domain, but they can be moving around various domains, right? They are not constrained to a mechanical or an automotive domain alone. I know people who are working on advanced data analytics tools, right? Where they could use those expertise to develop solutions for the EV industry.
Sir, could you explain more on the thermal management side, like on the cooling perspectives, like there you had showed about the convection and the radiator thing and all, right? Like, could you give some more information about what are the different practices which are used in like buses? Like electric buses means we need large amount of batteries, like huge batteries, and then a huge amount of power in like ultra capacitors and all might be used. Like I saw in some videos, like in China, they are using super capacitors to store energy. Like each bus stop they stop, like bus station where they stop, they get the energy. So a tremendous amount of energy should be taken in. So what are the cooling management systems which are present in those kind of systems? And
oh yeah, good point. Yeah, good point. So if you look at commercial buses or even cars, if I look at a larger systems where your capacities of motor and batteries are going to increase, we see a more focused on water-cooled systems, right? They're not convection-based, but they're more of water-cooled systems where the cold water, or I would say an ambient water, goes around the power electronics modules and they cool them. So that is approach that we take. And for batteries, I think more because of our tropical country, our India is a tropical country and we're having a lot of humidity and high temperature. What we see is more often people use air conditioned air into the battery cooling, or it could be chilled water for cooling the batteries, because batteries are happy to perform when they are between 15 to 25 degrees temperature, right? And if you have to take our vehicle, if you keep a step outside, even in the garage, or if your vehicle is parked in the hot sun, even at a 30 degrees temperature of its ambient temperature, you'll be around 35, 40, 35, 36 degrees. That is 5 to 6 degrees more than the ambient temperature because they are in a closed pack. So all of those are detrimental to the life of the battery. So it is advisable to have, or by design itself practice, they want to give a water-cooled systems for batteries. So that's a normal trend that we see in most of the Indian design perspective.
Sir, you can.
Yeah, so just a notion to participants and the lecturers today. I would urge that when you start giving your last 4th year assignments, for the project work to your students, I urge the students and the faculty to start looking at design solutions which has a multidisciplinary, maybe mechanical 2 people and electrical 2 people combined together, right, and do a project instead of having a 4 mechanical team member or 4 electrical team member doing this project. So I urge that you guys start looking that, because it only helps you to be better prepared when you go out to the market. And I'm sure you'll get bonus marks in case you go to an interview panel and say that we did a multidisciplinary project in my final year. So that will also give you some extra brownie points. But more importantly, you will be able to appreciate while doing a project how a mechanical, electrical things can be taken care. So maybe while you're doing a viva voce and review of the projects, we might have faculty from both teams, from both streams, to review it and give points rather than just doing a mechanical project or an electrical project. I think that's a common trend, and I would like to share this with the team, because that's the one reason that I want to get back to the institutions and see that what can we make change at the institution level, so that when they come to industry, they're much better prepared. Like I mentioned, there is no problem which is a mechanical problem or electrical problem. It's an engineering problem. So if you are a mechanical, in my team, personally, I have 26 people in my team, and there are a mix of both mechanical and electrical. When they go to the field for an issue, they go as an electrical engineer, EHVT, we call electric and hybrid vehicle technology engineer. He does not talk that I only look at mechanical, this is electrical, I want someone else to come and review it. So I think we should appreciate that fact. And I would urge that you, at least from the next year onwards, if you could start looking at that as an option.
Thank you, sir, for your illuminating session. We got to know about the design trends and available opportunities in EV. It was indeed an eye-opener. Thank you, sir. Thank you once again.
Thank you. Thank you. Hopefully it was interesting for participants as well. And you can reach out to me, Karthik sir, as my coordinates. You can be in touch with me. Thank you so much for your time, and be safe, stay safe, and good luck.